Alright, so welcome back to my backyard, and what I want to talk about today is some of the issues that you can get when you're running a statistical study, an observational study, or even an experiment. So last time we were in this yard and we were talking about measuring grass, so that's why we've got the ruler out. And one of the things that we talked about was how to pick a sample. There are issues when you go to pick a sample about whether or not you actually pick a representative sample. You want a sample that really represents the population. That's why we like to use a random sample. But if you use a different type of sample, sometimes what you get in your sample is bias. Now, bias is pushing the response in a particular direction. So why might we get bias? Well, one way to get bias is to get what's called sampling bias. So if I did a convenience sample by just looking at the grass right here, I might get some sampling bias. And the reason why, and it's kind of actually easy to see right here, is because I'm right in front of my garden. This is one of my wife's favorite places. And I made damn sure that I mowed this very well. In fact, I mowed over it 2 or 3 times just to make sure that it was nicely cut. So why is that a problem? It means when I go to measure the grass right here, I'm probably going to get all my answers close to that 3-inch mark, because that's what I was trying to get my grass mowed to, is about 3 inches. So if I measure right here, odds are I'm going to be pushing the answer towards 3 inches. On the other hand, if I was taking this video somewhere else and did a convenient sample, say in the backyard next to the fence, where I didn't mow as well, I might be pushing the answer in the direction of like 4 or 5 inches because maybe I missed some pieces. Other samples that have bias would be like the systematic sampling. Systematic, it seems like, oh, you went every 5 feet. Of course you went across your entire yard. On the other hand, think about how you mow. When I mow, I push the lawnmower down, and I turn it around and I go along this next path. There's a little space of overlap. That part of the yard that I mowed this way, and then I also mowed it that way, just to make sure I got all of the yard. That little space could be spaced every 5 feet. And so as I walk every 5 feet and look at a blade of grass, I could be landing on that spot that got overlapped, that got mowed twice. And so odds are I'm pushing the answer towards that 3 inches again. For the one where we talked about doing a voluntary sample, like if you go in a restaurant and ask a really crazy question, voluntary sample is certainly going to have bias, because in our example, when we said you go into a restaurant and you ask what people think of Donald Trump, it's got bias because it's pushing the answer in actually 2 directions. The people that actually volunteer their responses are people that feel very strongly. And the people that feel very strongly either love him or hate him. You're not going to have someone go, you know what, I want to jump into the middle of this crazy festival you guys have going on right here, where you're all screaming at each other about Donald Trump, whether you love him or hate him. I just wanted to let you know that I feel indifferent. No restaurant goer is going to jump into the middle of a gigantic fight to volunteer their response. You're not going to get a mediocre response. Just like if you go on Amazon and look for reviews. People either love the product or they hate it. Most people do not write a review to say, I bought this toaster and I feel okay about it. I give it a 3. In fact, if you look at responses, most of the time it's 5s or 1s. And most things have a good handful of 5s and a good handful of 1s. That's because voluntary samples have bias. Samples that do not have bias would be things like the cluster sampling, the stratified sampling, and then our favorite for this class, the simple random sampling. In a random sample, every individual in the population has the same chance of being chosen. That means that we're getting a representative sample. Think about it. If I took the die and I continue to roll it over and over and over again, every side has the same chance of being shown. I'm going to expect that I'm probably going to see a lot of 4s, I'm going to see a lot of 2s, I'm going to see a lot of 3s, and so on and so forth. It's the same idea, whereas if I have a question about the length of the grass and I actually do a random sample, I'm probably going to see, if there are a bunch of 3s, 3-inch pieces of grass out there, I'm probably going to see a bunch of them. And if there are a bunch of 3 1/4 inches, I'm probably going to see a bunch of those. I'm probably going to see a bunch of the different lengths that show up in the grass. I'm going to get a chance to see those because I'm randomly sampling. There are other issues with bias that show up in observational studies. One is participation bias. Participation bias is when you have a lack of participation. Maybe you have a lack of participation because people don't want to answer the question that you're asking. Maybe you're asking a very personal question and they just don't want to answer it, so they don't participate. And you're not hearing from them when you need to because that's what you're asking about. You can also have researcher bias. Maybe the researcher influences the actual study and the researcher bias would actually show up. You could have non-response bias, so people just don't respond. You could have bias coming from just the way the question is worded. Maybe I word the question like, you really like pizza, right? Like everybody else? Now, of course you have to say you like pizza. What if you're that person that doesn't like pizza? And now you feel like a fool for not liking pizza. You can't say that, right? So you don't. So then you get bias in that because really your answer was no, pizza's disgusting. I don't feel that way because who would feel that way about pizza? But maybe you do. So you'd end up getting that bias as well. Or maybe a police officer shows up to your door and asks you a question about crime. Have you ever committed a crime? Do you want to tell the police officer you've committed a crime, even though he's doing a statistical study and he's not going to arrest you or anything like that? I don't know. So you end up getting bias from stuff like that as well. In experiments, we talked about confounding variables. There's also this idea that you could have a single blind experiment versus a double blind. Single blind means that the subject doesn't know what treatment he got, or he or she got. So in a single blind experiment, you end up getting this idea that like, I don't know what's going on. The problem is that the researcher might know. And if the researcher knows, then if you say, take some Tylenol, and you say your headache didn't go away, I might say, are you sure? You sure it didn't go away a little bit? Because I know you took Tylenol and expected it to go away. So now I'm kind of biased then. Or if you didn't, you took the placebo and you're like, yeah, my headache went away. And I go, are you sure? You sure you don't still have a headache? That's because I know which treatment you took. So what you could do is you could run a double-blind experiment. Double-blind meaning that the researcher doesn't even know who took which treatment. Other things that could show up in an experiment, you could have non-adherers, people that don't follow the rules. So say that they're taking a cough medicine, and they're taking the cough medicine, they don't really think it's working, they start to think maybe they just got the placebo. So they know that back in the olden days, and this is true, like back in like the 50s and so on and so forth, the actual prescriptions used to be things like a hot toddy, which is whiskey. So if it was, you know, maybe they go and they grab a little drink of whiskey, a little hot toddy, to try to get the cold to go away. Now they've done something to add to that. So now maybe they think that it has gone away. So they're not paying attention to the rules, they're non-adherers. Or maybe they drop out of the experiment. They're no longer part of the experiment, so you don't get to see how things actually affected them. So these are kind of issues that could show up in an observational study or an experiment that you really kind of want to try to get rid of. And of course, during the class, we're going to talk about how you try to get rid of some of those things. Random sampling gets rid of the bias. How do you make sure that you kind of accommodate other things like the dropouts and the non-adherers when you're talking about experiments? How do you get rid of the confounding variables? And essentially the way that you try to do that is you try to anticipate those confounding variables. Anticipate who might drop out and for what reasons. And then try to attack that. So when we talked about the grass, one of the confounding variables might have been the sunlight. And if it was the sunlight, then maybe what we should do is we should try to make sure that we have some grass that gets, that every part of the grass gets the same amount of sunlight and so on and so forth. Alright, so I think I'm going to end the video there, and that was what could possibly go wrong with the experiment. So the experiments and the observational studies. And yeah, it's the same one, but it's actually, well, it just kind of as the second time you've seen this letter. Alright, see you later.